What is regularization in neural network training? Imagine you're trying to teach a robot to recognize different fruits. If it memorizes every tiny detail of the training images, it might struggle with new pictures. That's what overfitting looks like in neural networks. Regularization is like giving the robot some rules to prevent it from memorizing everything and help it learn the general idea instead. In neural network training, regularization is a set of techniques used to stop the model from overfitting. Overfitting happens when the model learns the training data too well, including noise and quirks, which makes it perform poorly on new data. The goal of regularization is to help the neural network make better guesses on unseen data by simplifying what it learns. Regularization works by adding constraints or penalties during training. These constraints make the model less sensitive to small details in the training data. The idea is that simpler models tend to work better on new data. This idea is similar to the principle called Occam's razor, which says that the simplest explanation is usually the best. One common way to regularize is called L2 regularization, or weight decay. It adds a penalty based on the square of the weights in the network. This discourages the model from having very large weights, which can cause it to fit noise. Another method is L1 regularization, which adds a penalty based on the absolute value of the weights. This encourages the model to make many weights zero, leading to a simpler and more interpretable model. Dropout is another popular technique. During training, it randomly turns off a certain percentage of neurons. This prevents the network from relying too much on any one neuron and helps it learn more robust features. Early stopping is also useful. It stops training when the model's performance on a validation set stops improving, avoiding the point where it starts to memorize the training data. Batch normalization is a technique that normalizes inputs to each layer during training. It helps stabilize and speed up the process. It also introduces some randomness, which can help prevent the model from memorizing the training data. Data augmentation and adding noise to the training data are additional ways to make the model more flexible and better at generalizing. In real-world applications like training models for image generation or language processing, regularization is essential. It ensures these models don't just memorize their training data but can create relevant and accurate outputs on new inputs. Regularization also makes AI systems more reliable and fair, reducing biases caused by overfitting. Overall, regularization is a key part of training neural networks. It helps create models that perform well not just on training data but also on new, unseen data. This makes AI more useful, trustworthy, and ready to handle real-world challenges.